single sideband suppressed carrier AM, that is Ssb Am. The Ssb signals will generated by three methods. So first one, frequency discrimination method or filter method. Second one, phase discrimination method or phase shift method. Third one, modified phase shift method or Weaver's method. So in this first method, frequency discrimination method or filter method, the message signal is, that is x of t, and carrier signal is cos omega ct, that will applied in the product modulator. The output of the product modulator is x of t into cos omega ct, that is a double sideband suppressed carrier signal that is present at the output of the product modulator, and this signal will applied into a band pass filter. So that will, the output is, the one sideband is suppressed. So finally we got the output is Ssb Sc signal at the output of the band pass filter. This is the first method of the frequency discrimination method or filter method. Next, phase discrimination method or phase shift method. So in this method we are applying the message signal or audio signal into a audio amplifier, that output will given to a balance modulator. So first, the BM1 input is directly, the message signal is given to the BM1, that is balance modulator 1, and 90 degree shifted message signal, that is audio signal, will given to the balance modulator 2. The AF audio frequency tone is 90 degree phase shift, then it will given to balance modulator 2. Same as the carrier signal. So BM1 balance modulator 1, the input is message signal and also the carrier is direct message signal is given to BM1, and 90 degree shifted carrier signal is applied into a BM1. Same as BM2, the 90 degree shifted phase shift message signal is applied in BM2 and the carrier source is directly applied. So after that, the BM1 and BM2, so that is balance modulator 1 output and balance modulator 2 output is added, then we got a Ssb signal. This is the following equation, that is BM1 will BM1, that is accepts the carrier with 90 degree phase shift from the carrier oscillator, and modulating signal is given directly. So another modulator that will accept the message signal with phase shift 90 degree and the carrier signal is given directly. So balance modulator 1 will accept the direct signal, that is Vm of t is equal to Vm sin omega ct, and 90 degree phase shifted carrier signal, that is Vc of t is equal to Vc sin omega ct plus 90 degree phase shift. That is it is represented in the equation form, that is Vm of t is equal to Vm sin omega mt and Vc of t is equal to Vc sin omega ct plus 90. So same as balance modulator 2 will accept the 90 degree phase shifted modulating signal, that is Vm of t is equal to Vm sin omega t plus 90 degree shift, that is direct carrier signal Vc of t is equal to Vc sin omega ct. This is the message signal and carrier signal for balance modulator 2. Then the Vm of t, the equation will represent as in Vm2, Vm of t is equal to Vm sin omega ct plus 90 degree, and also Vc of t is equal to Vc sin omega ct. So the output of V1, that is balance modulator 1 output, is represented as in V1 of Vm1 is V1 is equal to Vm sin omega t into Vc sin omega ct plus 90, because the message signal is directly given to Vm1 and carrier is 90 degree shifted. Then we can use the sin A sin B formula here. So this will change as Vm Vc divided by 2 into cos omega ct plus 90 minus omega mt, that is A minus B minus cos A plus B. So V1 is equal to Vm Vc divided by 2 into cos omega Ct minus omega Mt plus 90. So we can segregate the alphabets and numbers in one side. So minus cos omega Ct plus omega Mt plus 90. So that is sin A sin B formula is here cos A minus B minus cos A plus B. So the first term, the cos omega Ct minus omega Mt is LSB lower side band, and omega cos omega Ct plus omega Mt is upper side band. Next, same as output of balanced modulator 2 is V2 is equal to Vm sin omega Mt plus 90 into Vc sin omega Ct. Here that is V2 is equal to Vm sin omega Mt plus 90 into Vc sin omega Ct. So the message signal is 90 degree shifted, and the carrier signal is directly given to the balanced modulator 2. So we can use the formula sin A sin B here. So that is Vm Vc is common constant that will taken out. So Vm Vc divided by 2. So the formula is 2 sin A sin B. So here 2 is not present. So we can add multiply and divide by 2. So Vm Vc divided by 2 into cos omega Ct minus omega Mt plus 90 minus cos omega Ct plus omega Mt plus 90. That is cos A minus B minus cos A plus B. The sin A sin B formula is used here. So V2 is equal to Vm Vc divided by 2 into cos omega Ct minus omega Mt minus 90. We can segregate the alphabets and numbers in one side. So minus cos omega Ct plus omega Mt plus 90. So that is USB, and cos omega Ct minus omega Mt is lower side band. So finally we have a output, that is V0 is equal to V1 plus V2. So balanced modulator 1 output plus balanced modulator 2 output. That is our final output. So we can have the BM1 and BM2. So we can add. So finally we have the equation, that is LSB component have the phase shift difference, that is so plus 90 and minus 90. So that is in the out of phase condition. So hence they are cancelled each other. Therefore the only the upper side band components is present at the output side. So finally we got a Ssb signal at the output side. So third method is modified phase shift method or reverse method. So here the message modulating signal or message signal, that is audio frequency signal, will given into BM1 and BM2 directly. Then we have a BM3 and 4. In between we have the low pass filter, so 1 and 2. So BM1 is directly, the message signal is directly given to BM1, and here we are used two carrier signal, AF carrier and RF carrier. So AF carrier, that is audio frequency carrier, will generated from the carrier oscillator that will shift to 90 degree, and it will given to BM1, and directly the carrier signal is given into BM2. So the BM1 input is the message signal and 90 degree shifted carrier signal, and BM2 input is message signal and direct carrier signal. Then we got a Ssb Sc signal, that is double sideband output is appeared at the BM1 and BM2. Then we have a filter, low pass filter. So the double sideband signal will convert it into a single sideband. That means after low pass filter we have the output is only single sideband, either upper sideband or lower sideband. Then this signal will applied into a BM3. So low pass filter 1 output is given to BM3, and this RF carrier, that is radio frequency carrier oscillators, will generate some frequency that will given to BM3. Same as after the low pass filter 2 output is given to BM4, the RF signals, carrier signals will 90 degrees shifted and will given to a BM4. Then we have a adder, we add the BM3 and 4 output. Finally we got a SSB signal at the output side. Then we have a modulating signal, that is Vm of t is equal to Vm sin omega t, and carrier signal C0, that is subcarrier signal C0, that is AF carrier C0 of t is equal to 2 V0 sin omega naught t, and RF carrier signal, that is CC of t is equal to Vc 2 into Vc sin omega ct. So the input to the balance modulator 1 is message signal and 90 degree shifted carrier signal, that is AF carrier signal, applied into a BM1. So we have a formula, that is sin A sin B formula we can apply it here. So that is cos A minus B minus cos A plus B. We can apply. Similarly, the output of balance modulator 2, Vm sin omega mt into 2 V0 sin omega naught t, that is message signal and AF carrier signal. So both signal is directly given to BM2. So we have a output here also, sin A sin B formula is used here. So we can have the constant Vm V0. So in this above equation we have 2. So 2 sin A sin B formula is used here. So cos A minus B minus cos A plus B. Directly we can apply the formula. Then the LPF 1 and 2 will eliminate the upper side band of the balance modulator 1 and 2. So already we have the balance modulator 1 and 2 output. In this case, we can low pass filter will allow only the lower signals. So the LSB components will present at the output. The upper sideband, that is highest frequency components, will eliminate. So hence we got an output of LPF1 is Vm V0 cos omega ct minus omega mt plus 90. From BM1 output we can eliminate the upper sideband. We have the lower sideband components present at the LPF1. Same as LPF2 output, we can eliminate the BM2, eliminate the upper sideband components in the BM2. So then we have the equation, that is V0 Vm V0 cos omega ct minus omega mt, that is lower sideband components will present at LPF2. So then we can assume Vm is equal to V0 is equal to Vc is equal to 1. Then output of the balance modulator 3 cos omega naught minus omega mt plus 90 into 2 sin omega ct, because the output of LPF1 and the message signal, I mean the carrier signal, is directly given to the BM3. So we have the formula cos sin A cos B. So the sin A plus B and sin A minus B formula is used here. Then the output of the balance modulator 4 cos omega naught minus omega mt into, that is LPF2 output, into carrier signal is 90 degrees shifted. So we have the formula here also, 2 sin A sin B. So cos A minus B plus cos A minus B. So then we have the equation number 3 and 4. This is for balance modulator 3 and 4 output. So we can add this 2. So we can finally we get a output, that is LSB component present at the output of the adder, that is 2 sin omega c plus omega naught minus omega mt plus 90. So we can have the formula sin 90 plus theta, that is equal to 2 cos theta. Like that we can write 2 cos omega c plus omega naught minus omega mt, that is carrier minus message signal. So the LSB component is present at the output. So finally we have the SSB single sideband signal present at the output.